Okay, welcome back guys. uh, I'm going to give the summary for the chapter 5 Ethernet. So let's start. Ethernet. Let's start with the Ethernet protocol, and then the Ethernet frame, enter Ethernet encapsulation. As I said, the previous chapters, we have the different kind of layers: application, presentation, session, transport, network, data link, physical layers. That is also applied in the Ethernet encapsulation in the chapter 5. Ethernet is defined by the link layer and physical layer protocols. We have 80.2.2, 80.2.3, which is Ethernet. From the Ethernet encapsulation, most widely used LAN technology operates in the data link layer and the physical layer. Family of network technologies that are defined in the IEEE 802.2 and 802.3 standards. It supports data bandwidth of 10,000, 100, with 10, 100, 1,000, 10,000, 40,000, and 100,000 Mbps, maximum 100 Gbps. Ethernet standards define layer 2 protocols and layer 1 technologies. Two separate sublayers of the data link layer operate logical link control, or what we call the LLC, and the MAC sublayers. In the Internet encapsulation of the network layers, LLC sublayer, MAC sublayer, data link, physical layer, IEEE 8.2.2 standard, the Ethernet, and the MAC sublayer. Primary responsibilities: data encapsulation, media access control. And about the Ethernet evolution, Ethernet 2 frame structure and field size. We have the 8 bytes classified as preamble, 6 bytes classified as destination address, 6 bytes also source address, 2 bytes classified as type, 46 to 1500 bytes as data, 4 bytes frame check sequence. Ethernet frame fields. Minimum Ethernet frame size is 64 bytes. Collision, frame or run. Maximum Ethernet frame size is 1518 bytes. Jumbo or Baby Giant. Now the preamble, destination MAC address, source MAC address, ether type, data, and the FCS. MAC addresses and hexadecimals. So in the decimals and binary equivalents of 0 to F, we have the decimal conversion here from 0 to 0, 1, from 0 and 1. And the decimal numbers, infinite decimal numbers with a binary of 0, equivalent of 0 and 1, and also the hexadecimal partners with characters or letters. The MAC address Ethernet identity. Layer 2 Ethernet MAC address is a 48-bit binary value expressed as 12 hexadecimal digits. IEEE requires a vendor to follow the simple rules. Choose the vendors assigned OUI as the first 3 bytes. So all MAC addresses with the same OUI must be assigned a unique value in last 3 bytes. Organizationally unique identifier OUI, and at the other side the vendor assigned NIC interface from 24 bits to 24 bits, 6 hex digits to 6 hex digits, 00-60-2F for the OUI, and 3A-07-BC in the NIC. Cisco from the OUI and particular device at the NIC. Frame processing, the source and the destination. From saying this is not a saying that not addressing frame processing. The NIC views information to see if the destination MAC addresses in the frame matches the device physical MAC address stored in RAM. If there is no match, the device discards the frame. If there is a match, the NIC passes the frame up the OS layer where the encapsulation process takes place. And the MAC address representation. We have with dashes, with colons, and with periods. And we have here the unicast MAC address. Unicast MAC address or unicast IP MAC destination address are used by the source to forward a packet. And other side we have the broadcast MAC address, test MAC, source IP, test IP, the IP packet, Ethernet frame. Multicast MAC address of the multicast IP and MAC destination addresses deliver packet or frame to a specific group of members or hosts. Then we have the MAC address table. Switch fundamentals. An Ethernet switch is a layer 2 device. It is uses MAC addresses to make forwarding decisions. The MAC address table is sometimes referred as a content addressable memory CAM cable. Learning MAC address. I don't have this source MAC address and incoming port in the table, so I will add different MAC addresses here. Filtering frames. PCD sends frame with the other PC and switch learn PC MAC address. And now it's going to be filtered the MAC address. Filtering frames. Of the frame forwarding methods on Cisco switch. We have store and forward and cut through. Store and forward switches receives the entire frame and computes the CRC. The CRC is valid. The switch looks up the destination address, which determines the outgoing interface. The frame is then forwarded out of the port. A cut-through switch forwards the frame before it is entirely received. The minimum, the destination address of the frame must be read before the frame can be forwarded. Cut-through switching, fast forwards. Aside from fast forward switching, the lowest level of latency immediately forwards a packet after reading the destination address. Typical cut-through method of switching. Fragmentary switching. Switch stores the first 64 bytes for the frame before forwarding. Most network errors and collisions occur during the first 64 bytes. Deep memory buffering on switches. At this part, port-based memory. In port-based memory, buffering frames are stored in queues that are linked on specific incoming and outgoing ports. Then other side is shared memory. Buffering deposits all frames into a common memory buffer which all the ports of the switch share. And then we have the duplex and speed settings. Full duplex, both ends connection can send receive simultaneously. Half duplex, only one end of the connection can send at a time. So there's a difference with those. Then we have auto MDX. MDX autodex are types of connection requires and configures the interface accordingly. Now over here at the address resolution protocol, destination on the same network, physical address, the MAC address used the Ethernet NIC, and the logical address, the IP address used to send packet from the original source to the final destination. Introduction to ARP. ARP table or ARP function used to the map to find MAC addresses that is mapped to the destination IPv4 addresses. If the destination IPv4 address and the are same, the source IPv4, the device will search an ARP table for destination IPv4. Then, if no entry is found, then ARP request sent. ARP request message includes the target IPv4 address, target MAC address, then the ARP reply. The device with the target IPv4 address ARP request will respond with an ARP reply. A sender's IPv4 address and the sender's MAC address, destination MAC address, source MAC address, and the type ARP. So that's all for the chapter 5. Hope you like the video presentation. Oh, thank you.